We discussed the method of preparation of potassium permanganate from pyroxide ore. Today we can see the properties. Potassium permanganate has dark purple crystals, very dark in color. It is not very soluble in water. That is why we are preparing very dilute solutions for estimation. It decomposes at 513 Kelvin. See the reaction. 2 KMnO4 gives K2MnO4 plus MnO2 plus O2. You can see liberation of oxygen. KMnO4 is an oxygen-rich compound, so at a high temperature it decomposes and produces oxygen. When it decomposes, potassium manganate plus manganese dioxide is produced. It is diamagnetic, but it has temperature-dependent paramagnetism. At a certain temperature, it will behave as paramagnetic substance. Otherwise, it is diamagnetic. The manganate and permanganate ions are tetrahedral in shape. It is manganate ion. Here you can see 2 oxygen atoms represented as doubly bonded to manganese, but one is single bond with negative charge. This one also single bond with negative charge. And a tetrahedral shape like chromate ion. Chromate ion has tetrahedral structure. And permanganate ion, MnO4 minus, here 3 oxygen atoms are given through double bond and one is single bond with a negative charge. So very easy to remember the structure of permanganate ion, manganate ion, chromate ion and dichromate ion. Don't forget it. Sometimes you will get questions. Okay, now the chemical properties of potassium permanganate. Potassium permanganate, you know, it is an oxidizing agent. Potassium permanganate is an oxidizing agent, therefore it will undergo reduction. Potassium permanganate will undergo reduction. Potassium permanganate MnO4 minus can be reduced to MnO4 2 minus, that is potassium manganate, manganate ion. Permanganate ion can be reduced to manganate ion, MnO4 2 minus, or to manganese dioxide, MnO2, or to Mn2 plus ion, manganese 2 salt or manganese salt. So permanganate is undergoing reduction and these 3 ionic equations represent that reduction. Permanganate is an oxidizing agent, therefore it will undergo reduction. Here the first case, MnO4 minus plus E minus gives MnO4 2 negative. Addition of 1 electron. So plus 7, 2, plus 6. MnO4 minus plus 4H plus 3 electron gives MnO2 plus 2H2. And the third one, MnO4 minus plus 8H plus 5 electron gives Mn2 plus 4H2O. And it is the common reaction. In acidic medium, potassium permanganate is a good oxidizing agent, and it is the common reaction that is taking place during the reduction of potassium permanganate. In acid medium, first we can see the reaction in acid medium. Oxidation reactions of KMnO4 in acid medium. In acid medium, potassium permanganate can produce nascent oxygen. This equation clearly explains it. 2 KMnO4 plus 3H2SO4 gives K2SO4 plus 2 MnSO4 plus 3H2O plus 5O. 5 oxygen atoms, nascent oxygen atoms are produced. And these nascent oxygen can oxidize iodide to iodine, hydrogen sulfide to sulfur, Sn2 plus to Sn4 plus, Fe2 plus 2, Fe3 plus, oxalic acid to carbon dioxide and water. So these oxidations are possible. And from this equation, it is possible to write the oxidation reactions of other substances. For example, Fe2 plus, FeSO4 contains Fe2 plus. We can see the oxidation reaction of FeSO4. FeSO4 is oxidized by nascent oxygen in presence of sulfuric acid to Fe2SO4 thrice. FeSO4 plus 2, Fe2SO4 thrice plus 3. Increase in oxidation number, therefore oxidation. But in the first equation, 5 oxygen atoms are released. And here only 1 oxygen is consumed. Therefore, to equalize the released oxygen and consumed oxygen, multiply this equation with 5. After multiplying this equation with 5, you can add these two equations, then you will get the complete oxidation reaction of potassium permanganate. It is a total reaction. 10 FeSO4 plus 2 KMnO4 plus 8 H2SO4 gives 5 Fe2SO4 thrice plus K2SO4 plus 2 MnSO4 plus 8 H2O. Similarly, you can write other reactions. I am not mentioning that reactions here. Should not list one example to show the oxidation reactions of potassium dichromate and potassium permanganate. And this potassium permanganate can act as an oxidizing agent even in neutral or basic medium. So in neutral or faintly alkaline solution, the important oxidation reactions are these. Iodine oxidizes to iodide, not to iodine. Iodide oxidizes to iodate, not to iodine. In alkaline medium, slightly alkaline medium, iodide will be oxidized to iodate. Here you can see the equation. 2 MnO4 minus plus H2O plus I minus iodide gives 2 MnO2, manganese dioxide, plus 2OH minus plus IO3 minus iodate, IO3 minus iodate. Thiosulfate is oxidized to sulfate. This reaction is a quantitative, means we can use it for estimation. Therefore, thiosulfate can be estimated using potassium permanganate. Thiosulfate will be oxidized to sulfate. Another important example, manganese salt is oxidized to MnO2. Mn2 plus will be oxidized to MnO2. 2 MnO4 minus plus 3 Mn2 plus 2 H2O gives 5 MnO2 plus 4 H plus. In permanganometry, what is permanganometry? Estimation of various substances using potassium permanganate, that is permanganometry, volumetric analysis. In permanganometry, to create acidic medium, we are using sulfuric acid. Why hydrochloric acid cannot be used for the purpose? The reason, hydrochloric acid will undergo oxidation in presence of potassium permanganate. That will be oxidized to give chlorine. That is the reason. So HCl cannot be used. You will get question from this part. Why HCl is not used in permanganometry? What are the uses of potassium permanganate? In permanganometry, it is using in permanganometry, that is analytical chemistry. Potassium permanganate is used as a favorite oxidant in preparatory organic chemistry. For example, acids, organic acids are prepared by the oxidation of alcohols using potassium permanganate. It uses for the bleaching of wool, cotton, silk and other textile fibers. Since it is producing nascent oxygen, it can be used as a bleaching agent for the decolorization of oil. So oils can be decolorized by potassium permanganate. As a germicide, in well water, we will add potassium permanganate, and here it acts as a germicide. So it is enough for today.